All right, we are live on Facebook and on Instagram. Welcome back. I'm Dr. Boyd, the chemist, and today we're going to be learning about density. And here's what you'll need. You're going to need a small transparent glass or cup. I'm actually going to use again these little shot glasses, and um, if you don't have a glass like tea glasses or shot glass or something that small, try your smallest glass or cup. Again, I don't want everybody using up all their resources because I know we are in distressing times in terms of resources. So I have that. You only need one. You'll need some water. You'll need some syrup. I got some Aunt Jemima pancake syrup. You'll need some cooking oil. I'm just going to use, I can't remember, canola oil. And food coloring is optional. I'll use some just for effect, but you don't need it in order to do what we're doing today. So again, we're going to be talking about density. We'll be making a density tower. You'll need a small cup or glass that's transparent. You'll need some water. You'll need some syrup, like for pancakes, and then you'll need some cooking oil. And again, I'm not using large amounts of these items here, so you'll see. And we will get started in about a minute and a half. All right, gonna go ahead and get started with the lesson. Again, I want to emphasize a certain number of items each time. And the first thing is, do you recall what the most important thing that a scientist must pay attention to every time that they do an experiment or a reaction or even step into a laboratory? What is the most important thing that a scientist has to pay attention to? All right, safety. If you said safety, then you are 100% correct. Safety is the most important thing. Whenever I do an experiment, whenever I do a reaction, even when I'm just walking from one lab to another lab, I want to make sure that I can walk into that lab or do that experiment in a safe way, okay, in a safe manner. And so, what does the scientist do in order to stay safe? Well, some things that we do include wearing eye protection. In the case of eyes, most of the time you think of goggles, splash goggles, or safety glasses, all right? Also, we wear gloves on our hands. We want to protect our hands from picking up dangerous chemicals or germs or diseases and things like that. So I want to protect my hands. And of course, I do want to make sure I'm wearing the right types of gloves for the experiment that I'm doing. I also want to pay attention to my lab coat. I need a lab coat on because I don't want things to get onto my clothing or onto my body. I don't want to carry those things to my home or to my vehicle after I get out of the laboratory. So I'll wear a lab coat and can take that off in the lab, and therefore I'm not carrying it home with me. All right. So we are also going to talk about, once again, the necessity of having a lab notebook. You want to make sure you go to a lab prepared, and you cannot be prepared if you haven't written down what you intend to do. Okay, so you want to make sure you write it down. So for your topic today, the thing that you'll need to write down is density. And in fact, we're going to make a density tower, I'll write down how to spell density for those of you who are following along. A little marker here. I got my personal marker board. And again, our topic today is density. So I'm just going to write that in a hopefully legible fashion here. Okay. That's how you spell it. Density is spelled D-E-N-S-I-T-Y. Density. Density. What is density? What is density? Okay. So that's a question you might ask yourself and maybe put that in your notebook. I'm going to write down the mathematical equation, and we haven't done a lot of math per se in these lessons. So today, just a little bit of mathematics. All right. Density equals the mass of an object divided by the volume of an object. All right, so that's density. Density is mass divided by volume. So again, in your notebook, you want to write that down. I will show you what it looks like here. This is a mathematical equation here. You might see this in physics class. So density equals mass divided by volume. So what are those two things there? Mass and volume. What is mass? So mass is really, the mass is the measure of an object's resistance to acceleration when a force is applied. At least that's the physics definition of what mass is. The measure of an object's resistance to acceleration when a force is applied, okay? Resistance to acceleration when a force is applied, all right? What's volume? Well, volume is the amount of space that an object takes up, the amount of space that an object takes up. Now, those are kind of the more physics, mathematical definitions of those two terms, mass and volume. I wanted to mention them because we are talking about density, and you can get your density in a mathematical sense by determining the mass of an object and determining the volume of an object. You take the mass divided by that volume and you get density. All right. Well, we will not be doing a quantitative study of density today. We'll be doing more of a qualitative study of density today. As I mentioned before, we want to stay safe. Given the items that we'll be using, there is no need for goggles or gloves or a lab coat. You might put them on as an extra safety precaution, so you might wear, I do have some splash goggles here. Maybe you're concerned that you can splash some syrup into your eyes or some cooking oil into your eyes, so maybe you'd want to put these on, but you don't have to. These are not going to harm you. Also, you don't need gloves. Again, you might want to put them on just because this might get messy, get on your fingers, and you could throw the gloves away afterward, but we don't need them, all right? So density, again, is mass divided by volume, and we often see density in things every day. We understand that different things are more dense, so they may look the same. So imagine if you had a baseball and you had a tennis ball, and one of them is greater in density than the other. Which one is it? Well, typically the baseball is going to be greater in density than the tennis ball, okay? And typically the tennis ball and the baseball, they might be about the same size. They may be taking up about the same area of space or volume of space. However, the mass in the baseball is typically going to be greater than your mass in your tennis ball. And therefore, when you take that greater mass and divide it by the same volume, you, as with the tennis ball, you'll get a greater density, because density is the mass divided by the volume. All right. So we do see this, and we understand this intuitively and qualitatively. That term qualitatively means I'm not using mathematical numbers to come up with a precise value, but I can look at something and make an assessment with my understanding of it based on how I see it or feel it. All right. So the quality of of what I'm witnessing. Okay, that is the qualitative version of it. And that's what we'll be doing today. So today's lesson, I actually think will be kind of quick. We can expand it and do a few things. I am using here a shot glass. And in the shot glass, I am going to take some water and pour the water in the shot glass. So pardon me as I go get some water, and I'm going to fill this up about 1/3 of the way up with water. Now, if you're doing this at home with a larger container, you might want to do the same thing. You can fill it up about 1/3 of the way with water. So pardon me, I'm going to go to grab some water and fill this up about 1/3 of the way. All right, so I have my water, and you don't have to do this, but I am just for effect, and it'll make it easier to visualize some things. I am going to take some food coloring, just 2 drops, because I don't have a lot of water here, and probably 2 drops is overkill anyhow. I'm going to take some food coloring and add it to my water, and I am going to mix it up. So now I have water in that container. That's all I have in there with some food coloring. So it's green, so you can see that's pretty clear. So your first question for the day is, I have this wonderful Aunt Jemima syrup because I love all things sweet, and I drink my pancakes because I drown them in syrup. Don't do that, by the way. It's not good for you. I'm working on me. In any case, here's your question. I'm going to take some syrup and pour it into my container here. Your first question is, where will the syrup go? Will the syrup drop all the way to the bottom? Will the syrup stay on top? Or will the syrup mix with the water? Okay, that is your question. Now, what is your hypothesis? Remember, a hypothesis is an idea or a prediction, or in simplest terms, a guess that you can test. Okay, you can have a guess, you can have a prediction, or you can have an idea, but if it's not testable, then you don't really have a hypothesis. Okay, so what is your hypothesis? Do you think that this syrup, when I pour it in, it's going to sink all the way to the bottom, it's going to mix with the water, or it's going to sit on top? Write down your prediction, your hypothesis rather, in your lab notebook. Write it down, and then we'll go ahead and get started. I'll give you a few seconds to write it down. All right, moment of truth. I have some of this wonderful syrup that I'm not going to use too much of because I love syrup and I don't want to waste it. Check it out. So if you wrote down for your hypothesis that the syrup was going to sink all the way to the bottom of the container underneath the water, then you had a correct hypothesis. If you did not have that hypothesis, that's okay. It's okay to be wrong. Just make sure you're understanding why it is you're wrong. Take notes on it, take your observation, learn from it. Okay? So if you thought the syrup was going to sit on top, it didn't. That's okay. Write it down. No, my hypothesis was incorrect. My hypothesis was wrong. I was not right. This is actually what happened. It fell all the way to the bottom. Okay? Now, if your hypothesis was correct or incorrect, you want to know why. You want to know why that happened. So remember, our topic today is what? Density. We're talking about density. And again, this is more qualitative, and there's a lot more controls and math that I could include in the lesson, but just on a very simple level, I will tell you the reason that the syrup sank below the water is because syrup has a greater density than water. Okay? Syrup has a greater density than water. Again, for my folks on Instagram, if you can see that. All right? Let me make sure my folks on Instagram can see that. All right. Next question. I have this wonderful canola oil here. We cook with this sometimes. And I am going to do the same thing. that I just did with the syrup. All right. Now I'm going to take this canola oil or cooking oil and pour it into this container. Now this container has water in it and it has syrup in it, right? So next question, where will the canola oil go? Will it sit on top? Will it mix with the water? Will it go in between the water and the corn and the syrup? Will it mix with the corn syrup? Will it go all the way to the bottom? What do you think? What's your hypothesis? Write your hypothesis down. Again, a sample hypothesis would be, I believe that the oil will sit on a layer in between the water and the corn syrup. That's an example hypothesis. Or maybe your hypothesis is, I believe that the oil will mix with the water. All right. Or maybe your hypothesis is, I think the oil will sink all the way down to the bottom of the container underneath the syrup. Or another hypothesis might be, I believe that the oil will mix with the syrup. Yet another hypothesis, I believe that the oil will sit on top of the water. All right, these are just some example hypotheses, and we can test it. We're going to test it right now. Make sure you write down your hypothesis. I will give you a few seconds to write it down. Where will the oil go when I pour it into this container? All right, I hope you had enough time. Here we go. Are you excited? All right, I have an answer. You see here up top, this is where the oil was. Remember our water, we had dyed it green, and the syrup we know is like a brownish color. We know the syrup sank below the water, so the syrup is here, water is here, but the oil actually stayed on top. Okay, so again, what was your hypothesis? What did you think? What did you think would happen? Okay, were you correct? Was your hypothesis correct? What do you think? Okay, were you right about it? Why not if you weren't? Or why were you if you were? What was the reason that I gave for why the syrup sank all the way to the bottom of the water? Density. Syrup has a greater density than water, so it's sunk all the way to the bottom. Okay, so now we have the oil sitting on top of the water. What does that tell you about the density of the oil? What does that tell you about the density of the water? Write it down. Okay, I can tell you that the water has a greater density than the oil. Or I can say it another way. The oil has a lesser density than water. Okay? So what we've made here is what is commonly called a density tower. And the reason that this is working, or at least in part, is we have various densities of liquids. Okay? Also, these liquids don't mix easily, at least initially. Okay? I will tell you, well, you can stir them up and find out if they'll continue to separate out, but you don't have to. I will tell you what will happen just to save you some headache. The oil and the water, you can stir them all day and mix them all day. They will not mix. Eventually, what will happen, you'll get what we call a thicken emulsion. You'll see there's a lot of agitation. It'll look like they've mixed, but you let them sit there for a few minutes and the oil will come back to the top and the water will go to the bottom. The corn syrup, or I'm sorry, the syrup, however, will in fact mix with water if you stir it enough. And I don't think you can retrieve the syrup easily. It'll be like diluted syrup. You'll have a green diluted syrup if you mix those two. But you could add more. You could add alcohol and see where it goes. Okay, I would tell you. I think the alcohol would sit on top of the oil layer, and then you'd have water. You could add dish detergent and see where it goes. And as long as you don't shake it too much, these things should stay separate at least for a few weeks. speaking from experience. I've done it before. In fact, if you'd like to see a bigger density tower, I have one with 5 or 6 layers posted on my YouTube channel. You can find me on YouTube at Dr. Boyd, the Chemist. And you also can follow me. Make sure to subscribe to the Instagram page if you're not on Instagram. Instagram, I'm at Science Made Simple _ LLC. And I guess it's written on the board here. You can find me on YouTube and you can find me on Instagram. And I have begun to post all the lessons that we've been doing for the last 3 weeks on the YouTube channel, so you can go back and do them again and review them. And so all of them will be posted shortly. And I hope you learned something today. If you've done this at home, take a picture of it, take a picture with your children, post it somewhere on social media, Facebook or Instagram, and hashtag it Science Made Simple. That way I can check it out. I appreciate the parents for sharing with me some of the experiments that you've done after you've watched these live streams, and please continue to do that. All right, I hope you learned something. I will see you tomorrow at 2 o'clock. Take care.